Thank you. Hello. So the AI Impacts Project, our goal there is to answer various decision-relevant questions about the future of artificial intelligence. So at a high level, this is things like, when will there be something like human-level AI? What will it look like? What will happen after that? Will it be dangerous? And also, when will narrower AI happen before that will have large effects on anything? But we spend most of our time trying to answer sub-questions or sub-sub-questions that we think will inform these high-level questions. And today I want to talk to you about some of the sub-sub-questions that we've tried to answer and how we've gone about it and what we found out. So, to begin with, we'll take the when will AI be human level, and natural and popular way to try and inform our guesses about that is to go to AI researchers and say, like, when will we be done? And people have done this a few times in the last decade, and we did it again recently. Some people at AI Impacts and some other collaborators, we wrote to 1,600 machine learning researchers who had papers published in the top machine learning journals or conferences in 2015, and about a quarter of them wrote back to us. And we asked them lots of different questions, but one question that we asked, I think most of them, was when will AI be able to do roughly every task that humans can do, at least as well as a human, and at least as cheaply as a human? And this is a picture of their answers. You probably can't see very well in the background, but there are lots of gray lines there that are individual answers. So each line is the rising probability over time of human-level AI happening. And you can see this sort of all over the place. Some people think it's basically certain within about 20 years, and some people think it's very unlikely in 100 years. But with some things where people have answers all over the place, you can average together the answers and get a better answer. Like you can do this with jelly beans, apparently. In the past, we've sort of hoped that this would work with AI forecasts. And so we have this red line here that is the average of all the gray lines. But this time around, we actually tried asking several different questions that basically pointed at the same thing. And when people look at them side by side, they think that they should be very close together. But we got very different answers for them. So that suggests that it's not just that people have random variation and we can average their answers together. They're really quite biased by how you ask the question, at least. So the different ways we ask the question were the one I just told you, which has been quite similar to ways it's been asked in the past. And that's the blue circle-y line here. And then the red circle-y line is if you say, when do you think it will be possible to automate all of this particular profession? For like truck driving, and then we asked about being a surgeon, and being a retail assistant, and being an AI researcher. And then we asked when they thought that all of the occupations would be able to be automated. And then when they thought, first when they thought the very latest occupation would be automated, and then when they thought all of them would be automated. And so then you get this red line for when will all of the occupations be automated. People mostly agree that all of the occupations is a subset of all of the tasks that humans can do. And so the red line should be sort of to the left of the blue line. But really it's like 50 years later, which is quite a big difference. And the difference between the circle-y lines and the starry lines is smaller, but there it's just whether we asked, in what year do you think there'll be a 50% chance versus what do you think the chance will be in 20 years or 30 years or something. So in one case we're asking about probabilities in particular years, and in the other we're asking about which year would have particular probabilities. And while that's only a small difference there, I thought that was interesting because we used the same two framings across lots of different questions, asking about narrower AI, and just very consistently across the board, if you ask what will be the probability in such and such a year, instead of in what year will there be this probability, people say later times. My guess is that maybe they would just like to say low probabilities all of the time, so if you just give them years, they will always give low probabilities. Whereas if you say, when will there be this high probability of 90%, then they say, well, I guess a long time in the future, like 50 years. But speculation. But I think the important takeaways here are that people's answers to these questions are clearly very biased by the framing. We don't know if they're biased by other things, but there's at least that. So we should probably trust this kind of thing less than we might have otherwise. And the other thing is, as much as we're going to trust it, it seems like evidence that things are probably later than we would have thought, because the ways that we've asked AI researchers in the past get these blue circle answers, and it seems like every other way we could think of to ask them gets a later answer. So, but if we're going to trust that kind of thing less, what else can we do to answer this question? Another thing we did in the same survey was ask about lots of really specific narrow tasks and when AI would be able to do those. And for those also, we asked about multiple different times or probabilities. But this is like a summary of all of those as an average. So there are a whole lot of narrow tasks where the machine learning researchers predicted that we would be able to do them within the next 10 years. So now, even though their estimates may be bad, at least like in 5 years we can see how it's going. If we've done nothing in 5 years, then we'll know that they were sort of over-optimistic. And if we've done all of these things, then we can say, well, they were pessimistic. And if we have enough people answering such questions, we can maybe say who's good at predicting things or not, but I don't know that we have enough people here for that. Those are only some of them. This is not a very high quality picture that I put together this morning, so sorry about that. But this is all of the narrow tasks, the distribution of when they thought it would happen. So almost all of them are in the next 10 years for the average date when they think it will happen. I forget what the really long ones are. But I think it's interesting to look at a specific one too. So here is, when can we automate Taylor Swift? So this is, when can machines produce a song that sounds just like a new Taylor Swift hit, as well as Taylor Swift can, which means we can listen to them on Spotify perhaps, and also society might change in other ways. But this is the distribution of the likelihood of this happening in different numbers of years. So if we ask people, how likely is this to happen in 10 years, they have a lot of different views. More than half of them think that it's more likely than not, but it's pretty uncertain. But once we get to 20 years, it's still sort of uncertain, but it's basically guaranteed as becoming a very popular answer. And in 50 years, it's becoming an extremely popular answer. So these researchers think of themselves, I think, as pessimistic about like crazy AI things happening, and they often predict human-level AI being fairly far out. But they are willing to expect like quite striking changes to the current world in the very near future. So another way that you can break down the question and try to figure out when there will be human-level AI is to say, well, AI progress is some combination of hardware progress and software progress, broadly. And so maybe if we knew how important those two were and how they interacted with each other or something, we could just mostly forecast one or the other. And often people do this implicitly. When people try to forecast human-level AI, you might have seen them point to a graph by Moravec, I think, of a computer that's worth $1,000 becoming equivalent to more and more advanced animals, and saying, well, look, it will get to humans at this date. So that's sort of assuming that hardware is the main thing that matters. And other people sometimes assume that software is the only thing that matters. And if we knew where things actually stood, we could know which of those to ignore, or whether we should be combining them somehow. So this is just a picture of, in Go, you can see particularly that hardware and software can sort of replace each other. So these two lines are different Go programs where one of them is much better than the other for the same amount of hardware. But if you give it a lot more hardware, the worse one, then after that each doubling of hardware makes them look roughly the same. So along the bottom is doublings of hardware. This isn't that important, it's just an illustration that we do know for some things how hardware and software help. Like we can say there are these two Go programs, Fatman and Mogo, and we know how much extra effort it took to make the better one, which I think is Mogo. and we know how many years of hardware progress would have made hardware cheaper enough to make them equivalent. So we can try to figure these things out by looking at particular AI applications and plotting how much they were helped by hardware and software. Another way we can try to do this more easily, which doesn't work very well, is ask the experts again and hope that in their doing machine learning, they might have noticed how much algorithmic progress or hardware are helping. So we asked them for a range of inputs, actually, not just these two, also like funding and the size of data sets and things. If over the last 10 years, there had only been half as much progress in this thing, so hardware had only got 5 years worth of cheaper rather than 10 years, or there'd only been half as many algorithmic insights or something, how much worse do you think AI overall would have been? And so these are their answers for algorithmic progress at the top and hardware at the bottom, where answers on the far right are it would have been much worse, and answers on the far left are like, meh, it would hardly matter. So there are a lot of 50% here, and there is a lot of disagreement. I think one interesting thing here is that for the hardware one, there are a bunch of people who think that hardware is extremely important. Like 80% is the most popular answer here, or 80 to 90% there. But probably we have to go back to looking at things like particular AI if we want a clearer answer on this. We have tried to figure out how much hardware is in a human brain as a separate sort of project for figuring out what will happen if we had human-level AI, but also for if hardware matters a lot, you might, and you can track how hardware is improving, then you might think that when we have human-level hardware in some sense, we might have human-level AI. And the usual way of doing this is to try and measure how much computation a human brain can do, or to try and guess it, which is very hard because we don't really know what a human brain is doing, so we don't know which bits of it is a computation. So the estimates that other people have come up with, I could find 3 of them, and I think they varied by more than 10 orders of magnitude, evenly spaced, like 5 orders of magnitude and then another 5 orders of magnitude. So we've tried a different approach here, where instead of trying to measure computation, we're trying to measure the movement of information around. So for very big supercomputers, they've made up this new measure called traversed edges per second, or TEPS, which is like how quickly you can send a certain number of messages around inside the thing. Because once it's very big, it actually becomes a bottleneck how fast you can send the messages around. Like, big supercomputers can do a lot of computing, but if they can't get the thing that they just computed over here to the other side of the computer fast enough, then that slows them down. And the reason that this is a nicer way to try and measure the human brain is that we can actually see information moving around in the brain. Like, we don't have a great idea of how much information it is, but we probably have a better idea than 10 orders of magnitude of uncertainty. So if we suppose that the things moving between neurons are information, and that the neurons are sort of nodes, and compare that to a computer in the sort of natural way, which I won't explain here, we get an answer that the human brain is worth 0.18 to 6.4 times 10 to the 14 TEPS, which means something like 1 to 30 of the biggest supercomputer, or the one that does the most TEPS. And because we also know how expensive hardware is, we can say that this is about $4,700 to $170,000 an hour. Probably this should be more uncertain, but this is like the center of the distribution. And if we suppose that TEPS are decreasing in price at about the same rate as flops are, which is the usual measure of computing, then it will take until about 2022 to 2029 for hardware to cost sort of $100 an hour, which is perhaps the price of an expensive-ish human brain. We're not sure how fast the price of TEPS is reducing, because people have only been measuring them for a few years, but they seem to be sort of proportional to flops, so that's our best guess for now. But with this kind of number, you can also estimate how much hardware there is in the world and then combine them. So we thought how much hardware there is in the world would be an easy question to answer that surely someone was paying attention to. It turned out the last person who was paying attention to it was someone else at my own institution several years ago. And prior to that, someone else had looked at it in 2007 and also estimated how fast it was growing. So this other guy at Mary had sort of taken that number and then extrapolated it based on how fast it was growing and given a new number, and people have sort of accepted that. But when we looked at it and looked at the price of hardware, it suggested that the hardware that's in the world at the moment should be worth about 40% to 4,000% of the value of the world, which we thought is implausible. We've tried to estimate it again based on how much people spend on things like hardware each year and what could have plausibly gone wrong with those last estimates. And so we come up with these numbers, which are like 10 to 50,000 of the best supercomputers. But we can put this together with our estimates for how much hardware the brain is worth to try and guess if you turned all of the hardware in the world into something like a human brain level of AI, what would you get over time? There's much uncertainty from all of these different uncertain estimates, but I think it still reduces the options a bit. Because at the moment, it looks like all of the different scenarios we can think of, there are many fewer brains than the whole human world. So it's not like you would have something much more powerful than the world's population, at least on the basic estimate before you think about what might be done next. But the really big, so each of these lines is our estimate over time for how many brains you would get based on different parameters in the scenario. So the really big gaps are from uncertainty about how much hardware there is in the brain, where our number is somewhere in the middle near that best guess line. And then there's like a smaller gap between the pairs of lines from how much hardware is there in the world, which should probably be a larger gap, but there you are. And then the very steep slopes are the rate at which hardware was growing a few years ago, which it probably can't be growing at anymore. But this suggests that until about 2040 or something, it's not very plausible that you would get as much as the world's population if you did this. And at the moment, it would be something more like 1,000 people, it seems like, in our best guess, with much uncertainty between a tiny fraction of a person and millions of people. So a different question about what will happen after you have human-level AI is how long it will take to go from human-level AI to superhuman-level AI. And there are various reasons people have given to think that it might happen quite quickly. One of them in this top picture is, I think, given first by Eliezer Yudkowsky. The idea is we think of the village idiot as being much stupider than Einstein and this whole big range of humans in between with a few animals at the bottom and who knows at the top. But really, if we weren't so anthropocentric, humans would be all very similar to each other since they all evolved together and have similar minds, and most of the space below us would be animals, and then there would be a huge space above of other possibilities. But we can check something like this in real things where AI has reached human level. And I think the evidence there is against this, which is quite interesting. So the picture on the left is chess over time. And the dots along the top are human players, like very good human players. And the dots that are gradually moving up the graph are different chess programs. And so at the far left, in about 1950 and 1960, they're at the bottom of the graph there, and that's roughly amateur human level. Like if you take a human who hasn't played chess before, I think they're about there. And at the top, they become as good as the world champions. But in between, they just move very gradually across the space of human abilities. It took them from 1960 till 2000 roughly, so 40 years. And we see something similar in these other games at least. So in Go it took about 30 years and was mostly fairly incremental, except perhaps arguably not at the end. And checkers took 40 years. Physical manipulation I'm not quite sure about, but I think for many things it's somewhere in the fumbly level where it's like not superhuman and also not terrible. And Jeopardy, it took 3 years to go from winner on television to world champion, where winner on television is probably still pretty good among humans. So, and I think that happened fairly incrementally. So I'm not quite sure what is going on here. And these are mostly games, so maybe games are special in some way. But this is very much not what you'd expect, I think, from the initial thought that humans are basically very close in the space of intelligences. There, I think we would expect a long time with computers moving from really terrible up to the worst humans, and then they would quickly go from the worst humans to the best humans, and then they would continue above, which is, I think we've seen nothing like that in the things we've looked at. Another way that we've tried to figure out whether there will be fast movement from human-level AI to superhuman AI is to sort of question a common assumption, which is that there might sometimes just be very big jumps in AI progress. Like, we might have a great new insight, and then suddenly AI capabilities will go from like not great to superhuman. And the way we've looked into that is just looking at other technologies, like without any reason to expect that AI would be different. Like before we consider the possibility of an intelligence explosion or something, you might just expect the usual rate of very fast progress. So we've looked around for other cases of very fast progress, and this is actually still in progress. We offered bounties for a while for people to bring us very fast progress that they knew of. Not just that the slope is very steep, but that the slope goes from one steepness to like a much steeper steepness abruptly, is what we're looking for, so that it would be surprising. This is the second most abrupt progress we could find. I put it up because I have a better picture of it than the most abrupt one. And this is high temperature superconductors, the best ones they had over time. And I think what happened here basically was that they discovered that a whole new class of substances could be superconductors. And so the previous class, they were just finding slightly better and better ones. And then at some point they realized that their theories about what could be a superconductor were wrong. But I only looked into this for like a day, so I could be wrong about that. The other most abrupt one is how much bang you get for your buck in terms of explosives. And it went up a lot with nuclear weapons. So that's, I think they saw something. If you graph like how much explosive power you get per dollar over time, I think it increased by a factor of 4 or something over like, I think 1,000 years or something, and then it suddenly goes up by something like a factor of 1,000 or something. Like, it's really abrupt. But I think it's interesting that there also it's a case of like finding a new part of the physical space that we hadn't found before. Like both of these were discoveries in substances, kind of. Like they hadn't realized that you could, that like nuclear energy was a thing basically until shortly before then. And the other ones we could find were all, I think, less than 100 years of progress in one go, and only a couple of them were more than 10 years of progress in one go. And so we don't know how rare these are because we're just like looking across the space of all things for examples. But that we can't find that many examples suggests that it's not the norm, at least, and we probably shouldn't expect AI to very suddenly become much better from like an insight or something. Often, across all kinds of technological progress, there are great insights, but they don't cause very fast progress, usually in metrics that we can measure. So, those are all of the things I wanted to tell you about, and now I welcome questions.
So you showed these things about the prevalent cognitive biases in forecasts, and I guess that you basically had in like a behavioral economics paper. And Stuart spoke yesterday about the properties of the problem of forecasting AI that renders it very liable to cognitive biases and poor forecasts. Do you think this makes a case for kind of discarding forecasts in general, in attempting to deal with AI risk? And if so, what are the alternatives, or are they more reliable forecasting methods that we should turn to instead?
I think that if we knew what the biases were, then we could probably make use of the predictions. Like if we just knew that they were always 10 years too late or something, then that would be fine. So I guess I think they're still somewhat informative even without that, probably. For instance, I think it would be quite surprising if we got results like the ones that we get if the things that machine learning researchers were working on really looked to them like they were going extremely well. So I think this basically rules out that possibility, even though whether they say 20 years or 40 years is perhaps not that informative. Yeah, did that answer?
Have there been any joint studies with historians or sociologists? Because it seems to me that every century has its search for the elixir of life and its super beings like the golem, and then RUR robots, and you can track this back through the centuries. And if we assume human beings are going to be alive for several hundred or thousand centuries, perhaps there's a quite low probability that during this century we will achieve either the elixir of life or the ultimate super being. Has that kind of taking a step back and looking at it from that perspective been done by anybody?
Well, I think there has been some talking to historians and so on, but not about that particular question. What would you ask them?
Well, I'd ask them: are we being over-optimistic if we think that we are just going to happen to be the century that cracks both of those human goals that seem to iterate every century?
I guess I'm not sure what they would look at in history to be able to answer that question.
I suppose it perhaps it's more a psychological thing. Are we actually a bit like your initial slides showing the unreliability of the prediction market? Are we forgetting that we might not be as great as we think we are?
Plausibly, but I'm not sure how to answer that concretely with evidence that I have, so I wouldn't speculate too much. Yeah. I think probably some historians would agree with you.
Would any disagree?
Perhaps, yeah. The back there?
We have another look at the second slide.
Yeah.
It's just a practical note.
Was it this one?
No, the earlier with the nuance.
Oh, this one.
Right. That text is edges per second.
It's traversed edges per second.
That number I'd like to suggest is possibly to maybe 3 orders of magnitude small.
Why is that?
Everyone can see all the dendritic processes usually called sunlight in that picture, and they would be regarded as edges in the CA version of the tissue. There is a whole set of new class of edges that links all of the neurons directly by one site at the speed of light. And in fact, we cut them. And each one of those neurons is connected to the local neighbourhood by the field system. It operates in association with all the other activity on the dendritic processes.
I think that Anders wants to respond.
So they're not signaling at the speed of light. It's about the speed of sound. Like most neurons. And the dendritic computation, it's an interesting thing. It's been known for a fairly long time in computational neuroscience, but it gets rediscovered in the news media every 3 or 4 years. Oh, we have discovered that the brain can do much more. It's actually been modeled in standard computational neuroscience. So basically a neuron has about 8,000 synapses and about the same number of tree-like compartments in the dendritic tree. So at most you would actually be able to say that, yeah, maybe there is a factor of 1,000 of. But typically these dendritic computations are very particular kinds, so they are not very relevant edges here. Sorry.
Just to disagree, the activity that I'm most interested in is not to do with dendrites. The initial segment is the highest density ion channels, and just alone.
Okay, we should probably nerd out about the initial segment together. Yeah. It's probably getting off track here. Yeah.
It's deeply involved in dynamics.
Robin?
So the field of artificial intelligence traditionally has many other areas besides machine learning. In the last few years, there's been more progress in machine learning than in other fields. So we might expect machine learning researchers to be more optimistic about progress. They're going to first progress. So you made a choice to ask machine learning researchers as opposed to other researchers. How would you take that into account? Is it just that we don't need the other fields anymore, or you just have to be at that meeting and not the other meetings?
I think we would expect them to have earlier numbers, and we're hoping to just take that into account. I think choosing a set of artificial intelligence that seems representative across lots of areas of it seemed harder without that having some sort of unknown bias, whereas here we thought it at least should be over-optimistic, if anything. I think I actually forget which other considerations went into it. But I think it's interesting that they didn't actually have sooner numbers than the last time there was a survey, which surprised me because like they're machine learning people. All of this progress has been in machine learning, and the last surveys were not of machine learning people. They were people who had not been seeing much progress at all. So I'm not really sure what went on there. Yeah.
There's a lot of literature on psychological forecasting, and for instance, the Delphi method with all its pros and cons. Have you tried to look into that? And also the S-shaped, commonly, curves of progress, and try to plot the AI progress and see where the curve shape looks like.
I think we're just starting to look into whether we could do something with the Delphi method, so I don't have much to report back on it. But plotting progress in particular things, I have tried to do myself a couple of years ago, and I know that some other people have been doing it very recently, and we're yet to look at their stuff and integrate it with what we have. So yeah, I guess, again, I can't say that much about it, but I agree those seem like good things to do that we'd like to be doing more.